Good morning, everyone. Yes, I'm here to talk about Hedy, a gradual programming language for programming education that I made. But before we really go into the details of Hedy, I want to take you through sort of the history of Hedy and my history in teaching programming to children. So in the year 2013, that's getting increasingly longer ago as I give talks about this, I started to teach programming to kids. So there was a group of kids in a community center in Rotterdam in the Netherlands where I lived, and they needed a programming teacher. So I thought, these are little children. These were 10, 11, 12-year-olds. This will be fine. I have a PhD in programming, right, in software engineering. How hard can it be? How difficult questions can they ask me? This will be totally fine, I thought. It was actually a lot harder than I thought. And one of the things that made it really hard is that subconsciously, when I started to teach programming to those children, I thought back at how I learned programming when I was a kid. So this is me behind my dad's big computer when I was about 10 years old, learning to program. And how did I learn to program? Certainly not from another human. There was no programming teacher, no adults, my parents or friends of my parents, no one knew programming. There were no adults to really teach me programming. So I never really went through a programming lesson. I didn't really have an idea of what a programming lesson looked like. What I did have was this book. So this is a book from which you could learn programming at the time, and like I'm very old, so this is before the internet, right? Well, the internet existed, but I didn't have it in my house. So I had this book, and this book was supposedly going to teach me how to program, but it wasn't a book that said, oh, do this, you know, this is a variable, this is a loop. If you would open this book, this is what would be inside. This is printed out programming listing, right? And this is so old that it didn't come with a floppy or a CD or anything. You just had to manually type those codes into the computer to get it to work. And as you might hear from my English, English isn't my native language, and at this time I didn't really know any English. So none of the words really made sense to me. I just copied everything into the computer sort of until it worked, right? So that was really hard. And this is not just my experience. This is an experience many people, the children of the 80s, share. I saw some people like nodding in the audience. Many of us grew up this way, by learning from books and just hitting the keyboard until it worked. And that creates a certain culture of thinking about programming. Basically, we've all been sort of Stockholm syndromed into thinking that compilers are lovely teachers, right? Yes, this is fun. This is a good way to learn. It's just try things, and the compiler will tell me if there's an issue. With that in mind, I was teaching children in the year 2013 programming. So the children were very excited to learn programming, right? They were coming voluntarily to the community center on Saturday saying, hey, we really, really want to learn this. So I thought, okay, this will be fine. I'll just show them Python, right? Python is known for its easy to learn syntax. This will be totally fine. Here, children, this is Python. It's very exciting what we're going to do. We're actually going to print text on a screen. Super cool. And in order to do that, you have to type print, and then brackets, and then quotes, and then the text. And then what you'll have is text on the screen. So the kids were like, oh, okay, probably this is programming. This is fine. However, of course, it wasn't always the happy path. Sometimes kids made a mistake, an honest mistake, like this one. Accidentally using a capital P in print. Right? This sort of makes sense because you are supposed to start lines, sentences with capitals. What does Python say? Name print is not defined. Okay, so as an error message, it's sort of okay. It tells you what's wrong. This is not that hard. It got worse. Now I forgot a closing bracket. Just, one closing bracket. Seems like I'm very, very close. I should maybe get 9 out of 10 points for this. No. Python says no. Syntax error. Unexpected EOF while parsing. Right? Imagine you teach a bunch of 10-year-olds and one raises their hand and says, teacher, what is parsing? It's like, well, I don't want to talk about that now, right? I just want to talk about concepts. Here's another one. This is even worse, I think. Here, there's a space in front of the code. So everything is correct. Everything's fine. It is literally exactly the example that I showed them, but there's a space. So is Python happy? Can Python simply just ignore this space like you would expect? No, of course not. Indentation error, unexpected indent. Lesson 1, teacher, what is an indent? I was like, I don't want to talk about that now. This is too hard. Right? So over time, I saw kids getting more and more frustrated. They were very motivated in the beginning, but after a while, they were just like, if this is programming, never mind. I don't see how this will be fun on the other side. Some of them, of course, were like, okay, I know I want to be a programmer. I can take this pain for a little bit longer, but many of them disengaged by all of these small things. So I realized, okay, maybe compilers are not lovely teacher, right? Maybe this frame of teaching is just not a right frame. There was really a difference in what I thought was going on and what the children thought was going on. Something like this. This is a simple Python program which just lists 1, 2, 3, 4, or actually it lists 0, 1, 2, 3, but let's say for the sake of argument that this is just 1, 2, 3, 4. So what I wanted to talk about is repetition. I was like, oh, children, look here. This is conceptually the idea of a loop, the idea that a line of code can be used multiple times. But this wasn't what the children were seeing. The children were looking at the code and were like, oh, rules, brackets, colons, spaces. They couldn't really focus on the concept of programming, the concept of repetition, because they were so concerned with all the details. And I learned a lot, actually, about how people learn and how people process information. And I figured out that this is because programming causes too much cognitive load. If your brain has to think really, really hard, the technical term for that is cognitive load. And if you want to know more about cognitive load, I sort of went on a rabbit chase, and I learned a lot about programming and cognition, so much that I wrote a book about it. So if you want to also learn more about this, and there's a link at the end of the talk. So I wrote a book called The Programmer's Brain about how cognitive load and other cognitive concepts actually impact your programming. So I got so interested because I thought, well, we as humanity, we succeed in teaching children math, all children. We succeed in teaching children language, all children, not just the ones that are really motivated. So I was like, okay, how do other fields manage cognitive load? How do we do this? And one of the things that was so interesting looking into language education is that in learning to write, there are so many different ways to get it correctly, right? If you have a 5 or 6-year-old and they write like this, you will not say syntax error floating A, right? You'll say, if this is a 5 or 6-year-old, you're like, well done, buddy. This is perfect. Those are letters and not random scribbles. This is not wrong. This is not almost correct. This is just right. This is, at their level, the correct way of doing stuff. Later on, we add concepts. We say, hey, there's more than just letters. There's also words, and you can group the letters together, and then they form words. And then we add slowly different rules. After a while, we say, hey, every sentence now starts with a capital letter. Kids are like, okay, practice, 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 and they know this rule. And then we say every sentence ends in a period. Kids are like, okay, well, that makes sense. And there, this is not just syntax, right? Because we're also adding expressiveness to the language. Because once we have a period, we can make sentences that span multiple lines. Right? So our language is now more powerful because we have the concept of a period to separate different lines. So I was like, hey, rules gradually change if we teach language. How do we do that in programming education? How do we manage cognitive load? Well, not very well. We give kids the full syntax and the full language from the beginning. Right? And even when you say, well, in the first lesson, we just teach print, we don't talk about code blocks, inevitably, because the whole language is there, you might have to talk about it, because if you put a space there, Python will say indentation, right? So you're not chopping off parts of the language. You always give kids access to the full language. Like you would start, if you would teach language, with the full language, with all the bells and whistles initially. So then I thought, hey, couldn't we teach programming like we teach reading? Couldn't we also make a programming language that gradually changes? And then, as I said, I was just teaching these kids on a Saturday. It wasn't my plan to do anything research-wise. This was just a hobby, a volunteering gig. But I did have a PhD in programming language design. And I built an IDE when I was working on my PhD thesis. So I thought, well, I have the skills to build something like this. So I started to experiment with something that ultimately became the Hedy programming language that is a gradual language. So in the first level of Hedy, you just type print, and then you type whatever you want, and it just prints hello. And then gradually we add syntactic elements, and with that also concepts. So in level 4, we introduce quotation marks. And later on, all the way at the end of the trajectory, only then do we add brackets, because they're not necessary initially. If you're just printing one thing, you don't need brackets, right? So we made this language, Hedy, a gradual language. So I'm going to show you a demo with a few screenshots just to give you an idea of what Hedy looks like. So this is the Hedy user interface. It runs entirely in the browser, and that's by design because many schools and programming clubs cannot install software on their machines, either because they don't have the skills or more commonly, they just don't have the right access levels in computers to install something. So you just go to www.hedycode.com and you can start programming straight away. The code goes here on the left side, is where you type something like print hello and then print welcome to OpenJS world. And if you would run that, the output appears on the other side. So you see no brackets, no quotes, nothing. Kids can just focus on, hey, this is programming. These are the ideas in programming. Oh, you put some code here and then output comes on the other side. That's what programming is. What's also a really, really important part of Hedy is that we have built-in lesson plans. So everything you need to know is right there in the browser. Because one of the things I also found to increase cognitive load is if you have lesson plans on paper or even in another browser tabs, kids have to go from the one thing to the other thing. They read the lesson plan and they have to go to the coding environment, and that also creates extra cognitive load. So we put the lesson plans right there, so everything is sort of one in one package. What we also have is a cheat sheet. So if you push this button, all commands that are available in a level are shown to you. Because sometimes kids, of course, even though we gradually change the concepts, they might still forget what is there in a level. So we have these cheat sheets. What we also have is easy to read error messages. So you see now that I made a little mistake. I removed the I in print. Firstly, you see this because the syntax highlighter now no longer makes the keyword purple, but also if you would run the code, it says, we can't run your program. Print is not a Hedy level 1 command. Did you mean print? Like, this is quite actionable. This is stated, we hope, in language that kids can understand, and it shows you what to do next. And one of the reasons, of course, I mean, I am cheating a little bit, it's easier to generate these very, very meaningful error messages because the language is so small. In level 1, we just have 5 keywords, right? So it's relatively easy to guess what kids meant, which I totally understand why Python error messages are the way they are, because there are so many different things that could be the mistake. It's harder to guess. So a smaller language also allows for better and tailored error messages. What we also have in level 1, and that's quite important, is the idea of user input and output. So not just printing, but also asking. We have a keyword ask that is going to put an input prompt there, like input in Python. So it says, what is your name? And then you can type in the little green field, and the echo will repeat your answer back to you. So you get this idea of, oh, I'm storing a value somewhere, but you don't need to do anything. We just want to imprint upon children, programming, it's a thing where you have input and you have output. And just for comparison, right, if you want to do this in Python in your first lesson, have a very easy program that just asks for your name and then says hello name, this is what you have to type, right? So just the difference between this and this is so big for a novice. Right? Getting this right, making sure that all the brackets and commas and the quotes are there. For some kids, this is just a hurdle they will never cross, and then they give up because they decide programming is too hard. This is level 2. So in level 2, we introduce the idea of a variable more explicitly than in echo. So you can say, name is Hedy, age is 15, and then you can just say, print name is 8 years old. And if you run this, it will just output this. Right, so for us, programmers, we're like, this is weird. How does the thing know what is a variable and what is text, right? But of course, it's not so hard to do a little bit of static analysis to figure out what's a variable and what is text. Because we want kids at this level really to be focused on the concept of a variable and not on all the syntactic fluff. That will come later. So sort of Hedy does the heavy lifting of figuring out what's going on so that the programming experience is easy and only gradually increases. So I'm not going to take you through all levels. We have 18 levels now, and at the end of Hedy, in level 18, you're doing a syntactically valid subset of Python. So we really slowly want to get you to Python. And then our idea as well, if you're there, if you're at Python in level 18, you've seen conditions and while loops and for loops and variables and lists. You could sort of, from there, consume Python materials and enjoy the rest of your programming life in Python or in another programming language. But before we are there in level 18, just to give you a sense of what we have, in level 4 we add quotation marks, but then that's the only thing we add. So we really focus the attention of the learner on the idea that there's a difference between variables and plain text strings, and you have to tell the computer which is which. In level 7 we add repetition, but there also we start gradually. So the first way of repeating is just saying repeat 3 times, print, just on one line. No blocks yet, no for I in range yet, just a simple form of repetition. And that's also we gradually unpack to go towards a for loop. So one of the things we're super, super excited about is that Hedy now, as you've seen it, is in English, but we actually support multiple different languages, right? As I said, when I was first learning to program, I didn't know any English. So I saw the kids in my programming club, which are Dutch children, also struggle with error messages in English. So you can go to your settings if you have an account, which is free, by the way, and you can set your preferred UI language and also your preferred keyword language. So just if we set it to Spanish, everything will change to Spanish, including giving you the option to program with Spanish keywords. And we didn't stop at Spanish. I wanted to, but then people from the community kept pressuring me that they also wanted other languages, including right to left languages, which I didn't want to implement because it was a lot of work. But of course, once we did it, it's totally worth it. So we also support right to left languages. You see here programming in Arabic, where the whole UI, of course, is swapped. And also all of the keywords are in Arabic. We have Farsi as well. This also, as you can imagine, greatly lowers the cognitive load for children. You can imagine, well, it's hard to imagine for me, but you can sort of imagine that if Arabic is your first language and then you have to learn Python, that's like, right? That's for us, even non-English speakers, it's like this. And then for English speakers, maybe it's like this. But then if you have to use a different alphabet and suddenly the whole UI, everything is not like you're used to, that's a very, very high threshold. So yeah, it was a lot of work, but I think it's ultimately worth it that we now also support right to left languages. So before I close, I want to give you a sense of how stuff is going with Hedy, because as I said, I built this as a small research prototype for a research paper in one Christmas break in 2019. I built the first prototype in a few weeks, and then it sort of exploded from there, which was nice. One of the things a few months ago that was really nice is that I woke up to this tweet. This is Guido van Rossum. He's the creator of Python. And he said, I just discovered Hedy, a gradual programming language. A new idea how to teach programming to beginners. Very cool. And that this is really, of course, very, very, very nice to see. Especially because Guido van Rossum has once said that you shouldn't teach Python to 12-year-olds, which I think sort of I agree with now that I've tried. So it's really, really cool to see that he thinks also this is a good way to get kids into Python. So far, so we launched in early 2020, and over 2 million Hedy programs have been created worldwide, out of which 800,000 are unique programs. Of course, we have hello everyone in the database many, many times, but there are 800,000 different programs that children have created, which is like amazing. And so far, we have an error rate of about 25%. So 25% of our programs that children create on the website have a syntax error. And then you might be like, 25%, that sounds like a lot. However, we know from research that regular programming languages for novices like Java or Python have error rates around 50%. So we are quite happy with 25%, even though, of course, we're always keeping an eye on the error rate and we don't want to have too much errors because that means that the concept isn't very clear. But generally, we think we do a great job at smoothing the trajectory into full-size programming languages. Just so you know, Hedy is free and also open source. We're on GitHub, so if you want to contribute, we have, I think, over 100 open issues. So if you want to help out, that would be very, very nice. And you can't just help out with programming, even though we'd be very grateful for your help. We also like to add more languages. Currently, we support 25 different languages. As you've seen, English, Spanish, Arabic, also simplified Chinese, Hungarian. Well, I don't even know the list. We have many, but we've of course like to have more. And we use a tool called Weblate, where you can just translate in the browser. Even if you don't know any programming, you don't know any Python, that's not an issue. You just go to our Weblate link and you can translate some content there. So if you do want to help out in that way, we'd be really, really grateful. That's it. That's everything I wanted to share. If you want to follow me on Twitter, I'm @Felienne. If you want to know more about my work, then you can go to my website, felienne.com. If you want to read the book, The Programmer's Brain, that dives a lot deeper into all the cognitive aspects of programming and learning to program, not just for children, but also for programming professionals, you can go to felienne.com/book. And if you want to know more about Hedy, you can go to felienne.com/Hedy. Thank you very much.